Okay, today we are on 6-3, and we're going to learn two more things in this section about how to graph, finding the maximum R values, like how big will the actual graph have to be, which is nice to know if you're picking a coordinate plane or a polar plane, and where is it zero. So we're going to do that, and then the second half of today's lesson is looking at the names and the shapes, so you can tell from the equation what kind of picture it'll be, whether it'll be a circle or a inner loop circle or something like that. So some good things coming today to again help us graph polar equations. So the maximum values are where R is at its maximum. Okay, so like how far out does the graph go? Find the values for which R is a maximum, then substitute these values to find theta. So you do two steps. So you get like an R theta point, which would be the maximum. And I mean, so if it's a circle, like right here, it'll give you this point, how far out you go. And then the zeros are where it equals zero. So they would be like, where does that happen? So those things are nice when you're plotting the points to have ahead of time. So let's figure out how to do it. All right, so the first thing you do, and we're going to graph R equals 2 plus 4 cosine theta. Okay, and so we're graphing that. And we are looking for the maximum R value. Now, I've graphed it down here, but you're going to see how we got there. Okay? So, you realize, and this is the whole concept, you know that cosine and sine have to be between 1 and -1. You know, when we graph it, they only go up normally from 1 to -1, right? They go up here to 1 and to -1 here. So that's as far as cosine can go in its range. So what we do is we take the absolute value of R, the R of your equation, and then you substitute -1 in for cosine theta, because that's the least it could be, and +1 in, because that's the most it could be. So here we have R equals 2 plus 4 times -1, and you get a -2, and it's the absolute value of -2 because you're talking about it could go backwards or forwards, right? So that would be a 2 would be the maximum on the graph. And then you take the next one, absolute value of R, and you put +1 in for cosine, so 2 plus 4 times +1, and you get absolute value of 6. So we know, and I'm going to point right here now to the graph, that it's going to go out. Now we don't know where yet, but I've graphed it already, but we don't know where, but it's going to be at 6. So you know your graph has to have go out here as far as 6. Now we want to know what angle does that happen at. Where does that happen? So we substitute 6 in for R, and we say, okay, 6 equals 2 plus 4, and we solve for cosine theta. So this time we're going to find out what angle gives us 6, and then we'll know where it is on the graph. So simplifying that to 4 is 4 cosine theta. You got cosine theta equals 1. And so where's cosine theta equal 1? It equals 1 at 0. So we have a point right now. We know that 0, and this was the +6, is, I'm sorry, it's R theta, so I'm giving it to you wrong. It's 6, 0 is a point on the graph. This is R, and this is theta. So I know I have this point right here on the graph. Okay, now it only had one place, so because there was only one theta. There would be other thetas you would get if it was 6 other places. So we know there's only one. Now that was finding the maximum R values. Now we find the zeros. And to find the zeros, you set R equal to 0. Just like you set it equal to 6 down here. You set it equal to 0 to find where does it equal 0. So 0 equals 2 plus 4 cosine theta, -2 equals 4 cosine theta, so cosine theta is -1/2. Where does cosine theta equal negative 1/2? At 2 pi over 3 and 4 pi over 3 using the unit circle. So I know that I have 0, 2 pi over 3, and 0, 4 pi over 3 on my graph. Now, let's also figure out where it's symmetric, because that can help us too. It's a cosine. So if I do the polar axis, isn't that r negative theta? And if I put that in there, it will give me the same graph because of the cosine deal, where cosine negative theta equals cosine theta. All right, so I have that it's symmetric to the polar axis. So what you can do is draw a line, right, a dotted line or something right through the polar axis. And if you're looking at the graph, and I'm going to use red right now, if I plot this point and it's symmetric to the polar axis, that means it has to have that point. Okay, so it helps us, knowing the symmetry helps us be able to go back and forth. I know this point. I know it has zeros at 2 pi over 3 and 4 pi over 3. So here's 2 pi over 3. If I'm coming here, I have a 0 here. And 4 pi over 3, I have a 0. So we still have to do our points. So here we go. I'm going to use yellow to show you. This area here is us plotting our points. But we know some. We know 0, 6. And I know 2 pi over 3 is 0. So I was able to graph those. Now for shortcut, under y1, on your graphing calculator, put 2 plus 4 cosine theta. Make sure you're in radians. Okay? And then put in pi over 6. Use ask. Okay? And you know how I've showed you how to use ask. You go to the table setup. Okay? Table setup. And you change it, if it's just regular, to ask. Okay? And so you put pi over 6 in and you get 5.5. You put pi over 3 in and you get 4. And you could do that one by hand. And if you put pi over 2 in, you can do that one by hand, you get 2. So, and then I'm just going, why am I going around this unit circle? Well, because if it's symmetric to the polar axis, I do this point. I'll use green. This point, this point, this point, this point, this point, this point. And then I can flip all the points onto the other side. So at 0 it was 6. At pi over 6 it was at 5.5. So there's the point right there. I'm now graphing it. At pi over 3 it was at 4. Now wait, I'm going to go back up. At pi over 6 it was at 5.5. That means here at 11 pi over 6 it's 5.5. So you can do the bottom one too. Over here. And then at pi over 3 it was 4. So at 5 pi over 3 it's 4 also. So I'm doing the other side. And then at pi over 2 it was at 2, which means at 3 pi over 2 it's at 2. Now I'm not done. You've got to keep going, and this has an inner loop. So at 5 pi over 6, at 2 pi over 3, I'm sorry, I got to 0. So there's one point there. At 5 pi over 6, I got 1.5. So it was right here, which means there's another point here. So you can tell there's going to be an inner loop. And then at pi, you got 2. So here's pi, and I got negative 2. Sorry, I'm backing up, and I go to right there, that point. Okay, so I hope you could see that. So you have an inner loop here, and then you have an outer loop here. All right, so we found the maximum values, we found the zeros, we found the symmetry, and then we graphed it. Okay, so that's how you do these. And we'll do some more examples.